In this video, we look at FastAPI's built-in background tasks feature. You will learn what problem it solves, how to wire it into your endpoints with just a few lines, and just as importantly, when you should reach for a heavier tool instead. Imagine, a user registers and your handler needs to send them a welcome email. That email call might take half a second. The user does not need to wait for it. They just need a confirmation that registration succeeded. If you run the email call in line, you're making every client sit idle while your server talks to an SMTP server. And if you try to fix that by manually spawning a thread, you now own the error handling, the life cycle, and the cleanup yourself. Think about how a restaurant works. The waiter takes your order, hands you a receipt, and walks away. You are free to sit down. The kitchen is still cooking. That work is real and it will finish, but you do not have to stand there waiting for it. FastAPI background tasks give your endpoints exactly that pattern. Respond immediately, finish the side work afterward. FastAPI ships a class called backgroundTasks. You declare it as a parameter in your path operation function. FastAPI sees the type hint and injects an instance automatically, the same way it injects query parameters or dependencies. You then call add_task, passing the function you want to run, plus any arguments it needs. FastAPI holds on to that list and executes every task after the HTTP response has been sent to the client. Start at the top. We import FastAPI and background tasks from FastAPI. No third-party package needed. We define a plain Python function, send_welcome_email, that does the slow work. In the path operation, we declare background_tasks with the type background tasks. FastAPI injects a fresh instance for each request automatically. We then call background_tasks.add_task, passing the function and its two arguments. Crucially, add_task does not call the function right now, it just schedules it. The return statement runs next, sending the 201 response to the client. Only after that response is fully sent does FastAPI call send_welcome_email. Here is the full flow. The request comes in, FastAPI validates the body and resolves any dependencies, then your function runs. Every call to add_task appends a callable to an internal list. Nothing runs yet. Once your function returns, FastAPI serializes and sends the HTTP response. Only then does the ASGI server, UVCon or Hypercon, iterate that list and call each task in sequence. Because the response is already gone, any exception raised inside a task cannot change what the client received, so you need your own error handling inside those task functions. Background tasks shine for quick disposable side effects, sending an email, writing a log, clearing a cache entry. But they run inside the same process and the same event loop as your app. If the server restarts mid-task, the work is lost with no retry. For anything that takes many seconds, needs guaranteed delivery, or requires a retry strategy, you want a dedicated task queue like Celery or ARQ, which persists jobs externally and run them in separate worker processes. To recap, declare background tasks as a parameter, call add_task with your function and its arguments, and FastAPI handles the rest. The response goes out first, the work follows. It is a genuinely useful tool for lightweight side effects, but it is not a replacement for a proper task queue when reliability or scale matters. Know the boundary and you will use it confidently.